Screening a large number of compounds to filter out promising candidates is a common task in chemistry and materials modeling. In the Amsterdam Modeling Suite, we make use of an integrated Python library called PLAMS for this task. PLAMS allows us to create both very efficient and most customized workflows easily. In today's video, I will demonstrate how to set up one such workflow by combining a simple substituent screening with the filter for vertical excitation energies. As always, all the relevant code snippets and how-tos are found in the video description. In the examples section of the PLAMS manual, we can find a script that demonstrates how to automatically exchange substituents on a phenyl ring. Let's say we want to add an acetate to the list of substituents. All we have to do is to find the SMILES representation of it and set the point at which it should connect to the phenyl ring. I usually just copy the SMILES strings from Wikipedia, just like this. For the connectivity, I paste the SMILES string into AMS input like this. The bond should be formed to this carbon atom, which means the bond between hydrogen atom number 5 and number 1 should be removed. I added a couple of other substituents in the same way to make it a bit more interesting. Now when we execute the workflow, it will generate the structures and save them in the current working directory as XYZ files. I want to grab another example now from the PLAMS manual for filtering excitation energies and feed it all the new structures that we have just generated. Of course, I could merge the two workflows, but for a quick and dirty trial I can just change the line where the molecules are imported so that they are picked up from the current working directory. Now I can just run the workflow. It will apply a pre-screening with DFTB before calculating TD-DFT excitation energies of promising candidates with ADF. The filters are set to non-zero oscillator strength and a vertical excitation energy in the range of 2 to 4 eV. So after all the calculations are done, we find that out of all initial compounds, only phenyl nitride matched our search criteria. When you start creating your own workflows, then the PLAMS cookbook and manual are the best places to start, but there are also a couple of videos on this channel that showcase and explain the usage of PLAMS. I put all those in the video description as well. So that's it for today. I hope you found this useful, and as always we are happy to answer any questions below the video.